can just tell you it's summation n equals 1 to infinity with ln n.
What is it?
Summation n equals 1 to infinity.
Oh, just this guy? Yeah, he's a little smaller. Yeah, so we got that guy, right? Okay. So how do we do this?
S of k equals summation n equals 1 to infinity.
N equals 1 to k.
Oh yeah, 1 to k. 1 to k. You can do n equals 2. It's ln 1 to 0.
Well, we don't do that yet. We want to split them first. Right? So first thing we want to do is call this ln of k minus ln of k plus 1. Right? And then write it as two sums. Because the whole point is that we're only changing one of the sums, like reindexing one of the sums, right? God damn it. I did the NK thing again.
Oh, yeah.
Right?
What about the one on the left?
So these are separate sums right here. Oh yeah, it should be N. I see what you're saying. Like that, right? Okay. Where is it? It's good? All the N's are N's, right? It should be a K right here, that's right. Okay.
Now, the left is n equals n times 2 to k.
So let's focus on this guy. Well, yeah, okay. So no, actually, let's not look at this guy yet. Let's just look at this guy. Let's refocus him here, right? So we're going to take this, and we're going to say m equals n plus 1. M is only going to exist while we're doing this. Then we're going to kill m when we're done. We're going to turn it back into n's, okay? So notice that if n equals 1, then we get m equals 1 plus 1, which is 2, right? If n equals k, then we get m equals k plus 1, right? Those are our two limits right there. So now we're going to have the sum m equals 2 to k plus 1 of ln of m. Right? One second. Sorry, so this guy, so then we resolve to write him. I need to teleport backwards. There we go. we resolve to write him with n's instead of m's to avoid any confusion. Right? And then we say, hey, let's pop the top off. So let's write him only going to k plus the last term. So you take that and we plug it into here to figure out what the last term is. And it's ln of k plus 1. Right? And we say, hey, this is only 1/2 of this guy, right? So there's this other thing here. Oh, so it's minus this whole thing. But it's that in front. So if s sub k equals the sum n equals 1 to k of ln of n. Minus this whole thing right here, right? So we distribute because that's just kind of silly. Oh, there we go. Minus. Look at these two sums here. Yes, as you said, this we can ignore the first term here, right? Or we can think of it this way. Instead of ignoring the first term, we're going to take it out and we're going to put it over here, right? So we're just going to have this thing left over here, right? Oh, okay, so now we just have this nice little term. Oh, but this is 0, right? So now we can do our whole limit trick. Where are we at here? All right. Yeah, it's the negative sign. Right? So wait, let's try to do it without the sums, because the sums are cool, right? They're kind of confusing. So let's try to do it without the sums. So we start with this guy, right? Right? And yeah, we'll split it. Let's just write it split up, right? That makes more sense. ln of n minus ln of n plus 1, right? So then we think about this for a sec. All right, so yeah, so we have s sub 1 is just going to be the first plug-in, right? ln of 1 minus ln of 2, right? S sub 2 is ln of 1 minus ln of 2 plus ln of 2 minus ln of 3, right? And we say, hey, but let's see, let's do one more. S sub 3 is ln of 1 minus ln of 2 plus ln of 2 minus ln of 3 plus ln of 3 minus ln of 4. So we realize, hey, in each case, the answer is very easy, right? In the top case, should I go over there? Fuck it.
Yeah, so you're just going to be left with the negative.
Yeah, so I have S sub 1 equals negative ln of 2. S sub 2, I'm going to cross things out, right? That's going to go away. Brush grab. Equals negative ln of 3. Sorry. Yeah. S sub 3 is negative ln of 4, right? Because we cross out the same way. So then we just go, dot. I think S sub k is negative ln of S of k plus 1. Right? We look at the pattern, we recognize the pattern, we say, let's just do that. Which is sometimes commonly noted as S. And this is the same. Does that make sense?
No, yeah.
So keep in mind, this is using the same idea. Like we're not losing ideas. We're just writing them differently. And maybe this is easier to see, but in that case, this is perfectly acceptable. You write out the first couple partials. If you think it's telescoping, you write out the first partial sums and you simplify them, and then you say, hey, these simplified partial sums have something going on, right? And you generalize towards this guy. And then you use that guy to take your limit. How does that work for you? Let's see.
Thanks, honey. Finished class with an A minus.
Nice. Job.
Got 98 out of 100 on my final.
Okay. Let's do another determinant of the series convergence conditionally absolute or divergence. Nice logarithm.
Yep.
There's another human being watching calculus.
That's fucking funny. Let's see. I don't want this one though. I want the straight one first.
What are you trying to do?
Hey, wait. Let me play with this for just a second. This is kind of cool. 6, 7, 8, 9. Right? Okay. Nope. Oof. Oof. I need to make those darker. Get those guys to line up correctly. Did I? Only being able to put one image on here is kind of a bummer. Yeah. One. This be 10. This be 10. Go back to light.
So what do you explain what you're trying to do?
I'm trying to do. Oh, go away.
I don't know people that pay so much money to have pizza that just has nothing.
Huh.
Oh, like for reals, if you can pay like $20 for just like a regular pepperoni pizza, except it has arugula splattered on the top of it.
Okay.
Man,
So this should be a logarithmic scale, right? I should do reasonable numbers. Like I know. Light. Make it narrow. Call this 2, 4, 8, 16, 32, right? And then call this
what do you call that again? It's a logarithm?
2, 4, 6, 8, 10. So these tick marks, the purple tick marks, represent distances between, like, linear distances between numbers, right? And the lines on the grid represent logarithmic distances, right? So let's take something really simple, like distance equals rate times time, right? So let's say time
What math do you use?
is 2 seconds. Let's see if I can actually do this first before we discuss that. And let's say rate equals, I need to come up with a reasonable one, 8 feet per second, right? And we know that the distance you travel should be 2 times 8 equals 16, right? Feet, right? So here is going to be, I need something that's like bright, but will actually mark at the same time. Yeah. So here's 2, right? This is the distance, or this is the rate. Sorry, it's the time, right? This is the time, right?
Well, I fed him like almost a full can this morning, so you can probably give him the rest. Like a can a day, is that a lot?
We're supposed wants to mix it what? The solid.
Yeah, I can't find the solid.
Did I start far enough over? Or did I not start far enough over? Oh, I didn't start far enough over. I gotta fix that. And this should be the rate right here. Alright. Sorry, my bad.
So there's actually somebody watching.
So this should be 1. This should be 2. This should be 4. This should be, yeah. Right? 6. No, 8. This should be 16. So notice that when you add these two distances on the linear scale, on the log scale, they line up with the answer to their multiplication. Do you see that?
Yeah.
So let's try it again. So let's try rate equals 3 time equals 5. Then we know that distance should be 15, right? So then it should have, oh wait, no. How do I do this? I use marker. 3, and then we should have 1, 2, 3, 4, 5. 5. It's not lining up for me exactly. It's kind of problematic. I wonder if I'm reading it backwards. I'm trying to think. Am I reading it backwards? That's the question. So where would 3 be on the logarithmic scale? 3 would be right there, right? And then where would 5 be on the logarithmic scale? It would be right there. Then I have to add those distances. That's what I have to do. I don't have a compass. I need to take... see, I can't do this because I don't have a straight edge. I need to take this distance and stack it onto this distance. And it should get me about to 15 right there. Yeah. Yeah. I don't have a compass, so I can't really do this problem, can I? Oh, it's a bummer. Yeah, that's a tough one. You can do, it's how you do distance and rate time equations graphically. Oh well. To hell with that. What are we doing?
Alright, well you can pull up the images. And you want, go to the first page. You want that one. Yeah. So we're gonna do 10A. 10A, let me just see. So you have sigma, infinity, equals 1. So you have an alternating series. So we want to determine whether the series converges conditionally, absolutely, or diverges. So it looks like we're going to do the alternating series test because we have the.
Well, here I have a question for you.
Or you could do
if something converges absolutely, does it converge conditionally? I mean, yeah. If something converges at least absolutely, does it also converge conditionally? So here's my thought process here. I've got conditional convergence. Right, which is like this bubble. And then I've got absolute convergence, which is this bubble. Does that make sense? So if I show that something converges absolutely, I've shown that it converges conditionally, or at the very least that the idea of conditional convergence doesn't even make any sense anymore. Because the whole point of conditional convergence is that, right, it doesn't converge absolutely, but it still converges. So this is more important than this right here. We want to start with absolute convergence. All right, so ratio test. So we say, hey, I can do a ratio test. So I'm going to have the limit as n goes to infinity. So here I'm going to put -1 to the n plus 1 times 3 to the n plus 1 over 4 to the n plus 1 plus 1, right? Over -1 to the n, 3 to the n over 4 to the n plus 1. All of that in absolute value bars. Right? Where am I at here? Okay, so that's kind of ridiculous. So we resolve to make our lives easier. The first thing that we do is cross off these. They don't matter. Right? The second thing that we do is we organize this information more effectively. So we realize, hey, there's a big distinction between these guys and these guys. So we put the 3 to the n's on the top, or in one fraction rather. He goes on the top, he's the top of the top. He's the top of the bottom, well, you're still the bottom. And then the bottom of the top, well, that's still the bottom. And the bottom of the bottom is actually the top. You know, once you get that far down in life, like that's, you know, you're actually making it again. So we realize the absolute value bars don't really matter, so we kind of wonder why we're writing them and maybe stop writing them. So, yeah, this guy is 3, right? Right here. And what about this guy? Well, we resolved to fix him up a little bit. We divide everything by 4 to the n. And that means all 4 terms in the fraction. He still has a 4. So do you see? So we're writing this a lot just so people know we're doing the formula right? And then we immediately clean it up. Sorry about that. And then we go to divide it. So here these just cancel basically. We just get the 3. But then here we have to divide all 4 terms by 4 to the n. Keep in mind there's 4 terms going on here. 1, 2, 3, 4, right? So he becomes a 1. He is 1 over 4 to the n. He loses the 4 to the n but keeps 4 to the 1. So he's still 4. And he gets 1 over 4 to the n. And now that means that we are in... I don't even need to write this. We can take the limit at this point, right? Because all our limits are nice and tidy. They're all going to go to 0. 3 times 1 over 4. So he's absolutely convergent.
Yeah, that makes perfect sense. So the limit is less than 1, the ratio has convergence. If it's greater than 1, divergence.
Exactly.
Alright. Let me see if I can do this next one. Let me have a go.
Oh, you want the
Yeah. Let's see what I do. This next guy.
high five, Chantrell? Yeah.
Oh, you can see me. That's right. What?
I like messing with you guys because I know you forget.
Yeah,
Hey, where'd Wicket go?
he's over there.
What are you doing, Wicket? Oh, come here, boy. Come here, boy. Oh, he's a good boy. He's a digital dog. Can they? I don't think they can see this though.
No, the feed only sees the actual.
Yeah, it'd be really cool if we could show them that. It's actually really cool. It makes it a lot easier to not bump.
Yeah, it's like Tron vision. All right, so let me pull up my.
Like, yeah, you just chill.
He's just chilling.
Just chill.
I thought it was super cuddle time. You can just snapshot that.
Yeah.
Save to go.
Oh yeah, this guy. Touching my butt. Oh yeah. You can just keep it as a zone. All right, here we go. -1 to the n. Then we have over. So, conditionally, absolutely, or diverges. Okay, so first off, looking at this, what alternating series? I could compare this, right, to 1 over n, couldn't I? If b of n.
That'd be the wrong.
That's the wrong test to do.
No, that test would work out fine for you.
Yeah.
Right? Limit comparison test.
Yeah.
What's the power of n then?
Oh, don't you take the lowest power of n? What? So I would do 1 over root n?
N to the 1/3 power. Cube root n.
Yeah.
Right?
So what's wrong with
You just hit 1 over n.
Oh, well this is a of n.
That's who you compare it to.
Well, this is a of n.
No, that's the absolute value of n. The absolute value bars are on the wrong side. A of n has the alternating thing, -1 to n.
Oh, okay.
So
So
you want to pick the power that's closest to it. Equal to 1 over n to the 1/3. Right?
well, this is like,
That would be what kind of series?
well, this is a p series.
P series.
So p equals 1/3, which is less than 1. So if the power's less than 1, it diverges.
Right, P series.
So just diverges.
We want to know. Okay, so we've proven that it diverges absolutely.
Yeah.
In an absolute sense, it diverges. Can it converge without the absolute value?
It's a good question. So you would have a -1 over.
What test do we use first off? There's only one test that will show solution of convergence.
Yeah.
You take out of that thing when you take the absolute
Well,
value.
a negative one.
What is that called? What do I always call that?
What?
The alternating.
Yeah. Okay. So alternating series test. So alternating series test is limit absolute of a of n, right? Yeah. So we want this to equal 0. But we have to prove that this is decreasing and it's positive. So
Italy just took the world's longest pizza. It's a mile long and used 3,000
here,
pounds of sauce.
thank you, honey, for that wonderful. Okay, so it's decreasing and positive. So do I take the absolute value of this, or do I just look at it like Dad? Do I look at this? Well, okay, so I have to take the derivative. So n to the negative 1/3.
So wait, spread this out. Don't, because right now you're choking over your own equation. So take decreasing positive and write them behind it or somewhere else.
Here, let me just walk forward. Okay, so
start with positive.
So don't I take the yeah? So let's see if
Positive, you just say, hey, that's greater than 0.
no, yeah, you just look at it.
Yeah, so write positive and then write n to the negative 1/3 is greater than 0. There you go.
So take the derivative, so you get negative 1/3. So already right off the bat, you know it's going to divert or decrease or because you have this negative in front.
So get rid of that then. First say f of x equals x to the negative 1/3. Right, now under that say f prime equals, now do that. Say less than 0 for x greater than 1.
Yeah.
Right? So then you can write decrease. Share your knowledge.
Cool.
Boom.
So yeah, it satisfies those.
There's only one more thing to do.
Yeah, you just take the limit. So limit as lim as n goes to infinity of 1 over root n cubed. So this is just 1 over infinity, which equals 0. So it converges. Or well, didn't we just say that it diverges by p series? We have a conflict.
It's conditionally convergent.
Ah. So because that, oh, I see. Because it diverged when we did the p series, but it converges here, so it's conditional. Okay, so on the test, would I put it's conditionally convergent? So you just can't do the p series test. You should probably do, if it has an alternator in it, you should probably do the alternating series test, right? All right, let's see. Where's my?
So no, the p series test is telling you that it's not absolutely convergent, and so when the alternating series test makes it convergent still, you know it must be conditionally convergent by process of elimination. If we didn't do the p series test, we couldn't say that it wasn't absolutely convergent. Does that make sense?
Yeah. Okay. Well, let's go here.
So conditional convergence is kind of the most annoying one to prove because you have to prove first that it doesn't converge, second that it is.
Okay, let's find some. Let me save this guy.
Okay, start a new one. So let's do, let's choose a nice neon green.
Someone says we should do problems fast.
Well,
He's still watching me. To be fair.
sorry, man. It's hard to do it in VR. Alright, well, sigma n equals 1. I wonder if any of my classmates, like Mohammed, he said he was gonna.
I wish you could see who was watching.
Yeah, these are just, I posted it on Reddit, so it's just a bunch of random people.
You can't see the list of who's watching
Yeah.
unless they say something.
Okay, so find the radius of convergence and the interval of convergence for each power. So here, let me remember what we.
So it's the same test.
Yeah, you do the ratio test.
Right ratio test right now. Cool. Alright, so we say limit and goes to infinity. There you go.
Okay, so I just do n plus 1 over 4n plus 1 times x plus 1. N plus 1 divided by n 4 n x plus 1 over n.
Absolute value wise. And limit is n.
So, pick a new color.
I recommend you teleport over.
Yeah. I can type. Okay, so this guy will cancel with that guy.
Yeah, so don't forget, so limit is n goes to infinity.
Yeah.
Cool. Stack those two guys you just said.
So we get a 4 on the bottom, and then this n will cancel with this n. So let's see. So yeah, absolute value of x plus 1, and then there's an n plus 1. Yeah, n plus 1.
Put a 1 in. Put n plus 1 to the right. Because it's going to be n plus 1 over n. See that?
Yeah. Okay.
And what's going to happen with n plus 1 over n?
It'll go to 1.
Cross it out, put 1 in.
So we're left with 1/4 x plus 1/4 less than 1. Absolute value. That doesn't seem right.
1/4 absolute value of x plus 1.
Yeah.
No. You can't. No. Keep the 1/4 out.
Yeah.
Don't put the 1/4 in. Keep the 1/4 on the outside. Just write 1/4 absolute value.
Less than 1. Okay. So multiply both sides by, or divide by this, so you have x plus 1, 4. Looks like you're watching the actual feed, not. Yeah. So you have negative 4 x plus 1, 4. So you get negative 5 x 3. So the interval of convergence is negative 5 comma 3. And then the radius is 4. Well, oh yeah, we have to plug those in. So if we so we have to plug this guy in for x, right? So if we plugged in -5, we would get -4 to the. Alright, let me go somewhere else or teleport. Okay, so we will get.
Because I heard you like this little dessert.
It's kind of
You
dry.
guys haven't had it.
Pretty good.
Have you
But
had it before?
that one's the less dry one, isn't it? The other one is like all powdered. Purple one.
They're all powdery.
So look at this guy.
You need like a lot more.
So I have 4 to the n with the -4 to the n on top.
So then the 4s will go away and you just have -1. Be careful crossing out the -1 to the end.
Yeah, so you have -1 to the n, and then there's an n, right?
Right? Wait, now it looks weird. It's all smashed together.
Whoa. Chantrell's messing with the lines. Okay. What's looking weird?
Well, you wrote that stuff, so you didn't write equals or.
Oh, okay, fine. So,
What's that guy do?
do I take the limit of this?
Yeah, just take the number.
Yeah. No. Or I can I can double tap. So yeah, I can see it right now. Hello. Okay. So yeah, so this goes to infinity, right? Of this guy, lazy. Yeah, so diverge. So you wouldn't not include it. You would plug in 3. So just by looking at it, if you plugged in 3, you would get 4 to the n. So you would get infinity as well. So you don't include that one either. So yeah, so you'd do open parentheses like this. Cool. Next one. Okay. I do. Send it to him. I don't know if he'll watch it. I have him on Steam. See if he's on Steam. Yeah, he's my buddy. Go to Steam. Yeah, look for in the friends list, bottom right. Yeah, click on it. Scroll down. Look for Iceman. He might just be online. There he is. Just send a link. Just copy the link. Right there, Iceman. Yeah, so send message. Here, just double click his name. Right here, send message. And then go to the. No, to the right. It's like all the way to the right. Yeah, that guy. And now copy and paste that. He can see my feed of VR. So, like, everything I see, he sees.
Are you still doing the VR thing at school?
Yeah, on Monday.
After your final?
Yep.
Who reserved it for you?
So it turns out, so Goop, he reserved it, but he can't be there, and you need an instructor to be there. So, I'm just going to, like, there's a workshop room, and it's going to be the last day of school. So come on, who's going to be in the math lab? Like nobody. Everybody's finals pretty much is going to be over. So we're just going to set it up in the workshop room in the back and do it there. So kind of like a unofficial thing. Okay. So yeah, so all of these you just do ratio tests. So that's easy to remember. This is easy mode. Is she in the math lab right now? Or no, the math lab's closed. So this guy will cancel out with that end, just leaving a 2. Oh, that's where you got your shirt from. Okay, so I have a 2x minus 3 root n over root n plus 1, and then limit as n goes to infinity. So here, that's not, I can do this better. Root n over root n plus 1 of absolute value of 2x minus 3. So, here limit. How would I simplify this guy? Well, I get infinity over infinity, so can I do L'Hopital's? Oh, you just divide. Oh, okay. You can just divide that by n, and so you get 1 over 1. Okay, I see. So I'm left with this guy, which is less than 1. So I have 2x. So what I do it like this, where I just do 2x minus 3 less than 1 greater than negative 1, and now, so I have 4 less 2x plus well, brain fart, negative, or yeah, just 2. And then you divide, so I get 1x 2. So interval of convergence, and the radius, could I say it's 1?
It's half the length of the interval. So think about it. 2 minus 1 is 1 divided by 2 is 1/2.
2 minus 1. Wait, I don't understand.
Well, you have an interval. 1 is less than x is less than 2. Right? So the radius of the interval is half the length of the interval.
Oh. Okay. What? Is he watching? Oh. Oh, is she watching? Can you see me, Megan?
I think she just said brain fart and said
Lol.
Do you understand the idea of the radius?
Yeah.
Top number minus the bottom number divided by 2. Let me see the original series. We need to test the endpoints.
Yeah, you will, if you put them in to the original guy, so you would get negative 1 n over root n.
That would converge.
We already
did that problem, remember?
What, for the P series? Yeah.
Yeah, we did that guy.
Yeah, so we would include 1. So yeah, if you took the limit of him. Well, so like you do this, you do limit as n goes to infinity. So you get, yeah, so you have negative 1 to the n, well, divided by, don't make fun of my math. Well, the top, I divide the top by the highest power of n on the bottom, right? Which is n to the 1/2. Yeah, well, oh yeah, so it goes to 0. Yeah, that's what I thought.
It just goes to 0, yeah. You can just remember we did this problem.
Or 0. So, oh, so 0 isn't a problem. That means it's convergent. Okay, that's what I was. Oh, we know it's conditionally. Okay, so we don't include it. Yeah, so we don't include that either. So this guy, totally chill. All right, next one. Okay, here we go.
Come here, buddy. Look. Look at it.
So n to the n. Okay. Well, so we have x minus 5 to the n plus 1 over n plus 1, n to the n, x minus 5 to the n. So
No, don't do this. Don't do this. You do ratio test?
yeah.
No, do root test.
Oh, this won't work?
See the n to the n plus 1 in the lower left?
Yeah.
No, the other one. That should be n plus 1 to the n plus 1.
Oh, I see. Yeah, you're right.
Like, just do a root test. Because you can rewrite the original sum. And write the name of your test before you start them. Because you're live streaming.
Okay. So we're going to do root test.
Or semi-live streaming.
Yeah, there's a latency.
Oh.
What?
I literally have both screens on the delay.
Nice. Okay. What?
Yeah, Megan's watching.
That's funny. Behold the glory of calculus and VR. Oh no, it's an x minus 5. N to the n. So root test is what, of root a n? Oh yeah, nth root of n. As and then we want and then we'll take the limit as n goes to infinity of absolute value. Right? That's the deal that you do. Is that it? Is there anything else? Why do I feel like that?
Yeah, you need to be less than 1.
Okay, less than 1. Okay, well, so we're going to have absolute value, so x minus 5 to the n over n sub n limit as n goes to infinity. Yeah, they just disintegrate. Poof. Poof. So we're left with x minus 5 over, so we have 1 over n x minus 5 limit as n goes to infinity. So this goes to 0. So we just get 0, which is less than 1. What? Well, the radius is infinite, or all real numbers, right? Or
Yeah, the radius is infinity, the interval is negative.
yeah, so interval of convergence, you can just say.
The
Is this infinity? Oh, okay. There's a difference. Infinity. All right. Let's see. What's next? Oh, this guy. So, boom. So we have sigma n equals 1. Is she still at work?
No, she's never.
Oh, okay. Cool. X minus 3 to the n. So, we're going to do ratio test for sure. Okay. Divided by n. Okay, so this n will cancel with this n, leaving just an x minus 3. Oh, this is all absolute. And then this is really n factorial n plus 1. So this guy cancels out with him. Both our voices? Is it doing double? Oh, okay. Absolute of x minus 3. Yeah, so this is just eliminated. And then that's eliminated. So we have limit as n goes to infinity of n plus 1 times absolute of x minus 3. So it looks like we get infinity. So when you get infinity, the radius is infinity. And then the interval of convergence is all real numbers.
No, think about it. We forgot to do something. It's infinity, you have to say it's less than 1.
For ratio test?
Yeah, you always force it to be less than 1.
Oh, okay. So, well, doesn't make sense. Infinity is not less than 1. I don't know what do you mean?
Infinity is never less than 1 in divergence.
Oh. So there's no radius and there's no
There's no interval of convergence. The only number for which convergence would be possibly 3.
Oh, okay. If you get okay, so previous problem we got 0, so that means the radius is infinite. Okay. Infinity diverge by a s t. How many people are watching now? I'm like curious. Wow. I'm like surprised. Those are like just random people on Reddit, I guess, and Facebook. Like, or maybe it's Vargas.
Megan said it was helping her fall asleep.
Oh, that's good.
So the guy came over, she's like, no, just stay there and keep talking.
Yeah, I guess people would rather see me just draw like squigglies in 3D. Okay. Next one.
Wait, no, series test, let's group test. Doesn't matter.
No, we did. That was an plus 1 divided by an. You're confusing the previous problem.
No, that was the group test.
What? This? No. I totally did this.
Yeah, which is well, no, that's the ratio test.
Yeah, ratio test.
Oh yeah, no, sorry, that was the ratio test.
Yeah.
You're alternating series test.
Oh, did I?
It
Oh,
doesn't matter.
I'm tired. How much VR math have I done today?
You've done like hours.
How much longer of your math are you making?
What time is it?
2:30.
Probably like another 30 minutes. Or what do you think, Ted?
I don't care. I mean, yeah, probably after like an hour or so. That's about the most I can do. I don't know get through this. So.
Yeah, that's also my 30 minutes minimum.
I have a test on Monday.
That's how it's in the humor.
Hmm?
That's how it's in the humor.
You know what happens, honey? If I get a C on this test, we're homeless.
Homeless.
Yeah. Nigga no get no job. Nigga no get no money. Nigga no get no money. Nigga no get no BMW 7 Series. Okay. So find the power series representation of f of x equals arc tan of x. So this is just the thing you memorized, right? It's I told you this earlier.
Yeah.
So it's
Well, he does fine, so you need to prove it, but you already know it.
yeah, it's this. Oh, wait. I remember how we proved it. So f prime of x equals 1 over 1 minus negative x squared. Hey, that looks like it's geometric. So then you go like this, infinity, n equals 1. So our r is this guy, and our a is 1. So you have negative x squared to the n.
Wait, start your index at 0.
Oh. Okay. And then divided by n factorial. So why do I feel like what am I missing here? So I have a negative 1 to the n times x to the 2n over 2n factorial. What am I doing wrong here?
Well, I don't know what you're writing. Don't like that. Whatever you're writing, don't like that. That's not right. So what is that? What the thing we just had? It has an equal sign. It's f prime of x, right? That
Yeah.
equals f prime of x.
Yeah.
That's good. No, that's good. I'm cool with that.
Okay.
But where did the over n factorial come from? That doesn't make any sense.
Are you watching the latent feed again?
No.
So this thing you can.
Yeah, there shouldn't be an n factorial.
Oh, okay.
It's just n.
Okay, it's just n.
AR to the n minus 1. Sorry, I wasn't paying attention, and then Megan messaged me and told me that you were doing wrong.
Oh, AR to the n minus 1. Okay, we said r is okay. So yeah, so a is 1. R is negative x squared. So we have a negative 1 n minus 1. No. Negative 1 n, and then we x to x squared to the n minus 1.
What are you doing?
Well, I'm putting it in this form. This I'm just plugging in a and r.
Okay, wait. Then the negative needs an n minus 1.
Oh, okay.
Okay, good. N equals 1, 2.
Okay. Okay, now there's something else that needs to be done. What is it? Well, I have a 2n. I bring this guy out, right? So I have a 2n minus 2, right?
Okay.
But there should be something on the bottom.
No, that's it. What is that equal to? That's sum.
Oh, this is equal to. Oh, I see. Oh. Ah. Yeah. Now I remember what to do.
So then
Now you integrate.
f of x is going to be the integral of that. And you only need to put your integral around the x's. So your integral really only has to encompass the x's.
Okay, so integral of, so we have the summation on the outside of everything that isn't an x. Okay, so we have a -1, n minus 1, and then we have an x 2n minus 1. So we 2n minus 2, right? So we add a power, so we get x to the 2n minus 1 divided by 2n minus 1. Is that right?
Yep.
And then
-1 to the n is n minus 1 is still there. It doesn't change. So put the rest of the stuff back on.
yeah, so now we just have a -1 n minus 1. Why do I feel like this isn't the formula in the book?
In the book, it starts at 0. It has a plus 1.
Oh,
So say equals. So this is right? And then say sum, write the sum again. That won't change. But now
n equals
0. So here's what we're going to do. So we're going to decrease the index by 1. So everywhere in the formula where there's an n, you're going to put an n plus 1.
oh, okay. So
n plus 1 minus 1.
which is n.
X to the 2n. It's going to end up being exact.
So you get 2n minus or plus 1. Ah, that looks cool. Yeah, so you get 2n. That's what it is. Yeah. So finally equals. And that's how you prove it. Oh my gosh. And then n equals 0. Cool. That's pretty awesome. Okay, let me look at the hardest one. Where'd it go? Oh, that's not what I want. Okay. Let's do yeah, let's do 13. Evaluate this as a power series. Okay. So, we want to do this as a power series, huh?
So now we just use your magic formula.
The magic formula.
The one that you memorized that you used last time because you're trying to exploit it.
Oh yeah, because okay, so we know that yeah, tan inverse of x equals n equals 0 to infinity of -1 to the n x 2n plus 1 over 2n plus 1. Cool. And so we have that, and then there's a 1 over x in our integral. So so I think we just pull out everything that isn't an n, huh? Or an x. So we're going to have this of -1 to the n over 2n plus 1, and then integral of x 2n plus 1 over x. Right? Does that look cool?
Sorry, 1 second. What's that?
So I just pulled.
I like it. Yeah.
So then I just subtract.
Dx.
Oh yeah, duh. Dx. So, what do I do about this?
What you were saying makes sense.
To subtract an x power, so I would just get x to the 2n.
Exactly.
Okay, so
It's next to the 1, so that 1's
yeah. What am I doing? I don't know what's happening. Okay, x to the 2n dx. So I get x to the 2n plus 1 over 2n plus 1. And then times. So I multiply it by this, right? So I get yeah, so this is it. So if I were to clean it up, it would just be 2n plus 1 squared. And then I would leave it like this, and this is the power series. Okay.
I don't think it asks you to find it.
Well, oh, radius of convergence, huh? Well, you'd have to do. Did it ask that?
Yeah,
Or-
it does.
Oh, okay. So now I have to take him, huh? And here, let me teleport over here. So now I just take that whole thing I found, and we're gonna do ratio test, right? That sounds like a good idea. So we can just ignore the negative 1. So we have x to the 2n plus 1 plus 1 over 2n plus 1 plus 1 squared times 2n plus 1. Here, I have to teleport. Yeah, I need to adjust the width of this room over 2n plus 1 squared over x 2n plus 1. So I gotta FOIL this guy out. So I'm going to get 2n plus 3. Yeah, x to the 2n plus 3 on this guy. So 2n plus 3 on the bottom squared. So this n will cancel with this n and that 1 with that one. So we're just left with an x squared on the top. And then, do I have to FOIL this guy out?
No. Just stack the 2n plus 1 squared over the 2n plus 3 squared. You realize it's going to go to 1. Like, essentially, because you have the same power of n, you have 2n plus 1 squared, 2n plus.
Well, don't I get the n's cancel out and I just get an x squared? So the n power goes away.
Yeah, the n's aren't even not the nth power. So for the x's, you'll have x squared, right?
Yeah.
Absolute value of x squared.
Mm-hmm. Yeah.
2n plus 1 squared. And then 2n plus 3 squared.
Oh, you just stack them like.
To 1. Like, they're going to match from the limit.
Yeah. It doesn't matter what. Okay, I see what you're saying.
So you don't need the 4. You're fine. Like, it'll just go to 1.
Yeah, because you divide. Okay, yeah, it goes to 1. Okay. Yeah, so I'm left with this, which is less than 1. So, I take the square root of both sides, so it's still 1. So the radius is 1, and then the interval of convergence is -1, 1. And then to test if you include them or not, you just plug them in for x, and then you take the limit as n goes to infinity, right? Is that what you do? You just plug in each x value, and then you do ratio tests, or do you just take the limit right off the bat? Hmm.
Let's see. once you so yeah, the ends the limit will go away, and then you're just getting x squared, right? Absolute value of x squared,
Oh,
right?
well, no. When you plug in -1 for x and
Oh, I
1,
see what you're saying.
yeah, to see if you include them or not.
Yeah, either way you get a piece of reason. But you would need to test the endpoints. I don't think he asked you for that though.
Oh no, he doesn't.
He only asks you for the radius of convergence, so you don't have to test the endpoint. So
Oh.
once you can find out that the radius is 1, you're done.
Okay.
Because otherwise it's just kind of
Woo. Okay. I think I'm math VR'd out for tonight. But yeah, could you come over tomorrow and help me some more?
Yeah.
Okay. Well, shut her down.
people were actually
Ugh.
Robert McGregor.
What?
Yeah.
Robert McGregor? What the heck? I'm wearing a kilt, Robert McGregor. No way. Welcome to the clan.
You know Robert McGregor?
No, but he has the same last name as me. That's so cool. Well,
Yeah, tell him we do this.
yeah, we've been doing this a lot. I just figured out how to stream. So tomorrow in the morning, I'm just going to be doing this. I don't know how you add or whatever, but yeah, I've been doing VR math for quite some time, so I'm gonna take a break. But yeah, tomorrow morning, like 10 a.m. Pacific Standard Time, I'm just gonna be doing this all day. So if you're interested in seeing VR math, you can tune in then. But goodbye, Clan McGregor. Royal is our race. I'm serious though. I'm wearing a kilt.
Did you respond to him?
Yeah, I'm just talking to him. There's a latency. So goodbye.
Oh, I see.
Yeah.